So first of all, we have to know what is quantum. Quantum is one of the four branches of physics, and quantum is about the smallest building blocks of nature and their strange behaviors. I can give you some examples like electrons, photons, protons, etc. are the examples of quantum. Then our first topic is the dawn of the quantum age. In the dawn of the quantum age, scientists found out new kinds of features, and there features are the universe is built on quantum rules. From classical physics of 19th century, we evolved to the quantum mechanics, and from quantum mechanics, we are now in quantum technologies. This is an example of classical physics, a pendulum oscillation, and this is an example of quantum mechanics, where light is acting both as particle and as wave form. This is the example of quantum technology, and that is the father of quantum mechanics, Max Planck. Then let's go to the second slide. We are not entering the digital future, we are entering to the quantum future. With this, let's start the second slide. Science is quantum is not just a science, it's a superpower. With this, start on the quantum potentials. Quantum computing. In quantum computing, we are making superpower computers which will be millions of times faster than the normal computers. Then quantum communications. In quantum communications, we are making unhackable and unrestrictable path for our communication to transfer. In quantum sensors, we are making sensors by which we can detect any virus or minerals underground or under the water. In quantum medicines and healthcare, we are making medicines to treat cancers and diseases which can not be treated in this era, and we can also use this to treat people for their healthcare facilities. The national security and defense. ISRO and DRDO are making encrypted satellites, and that would be helpful for national security and defense enhancements. Then economic growth and innovations. By using quantum computing, quantum communication, quantum sensors and medical things, we can improve our economic growth and innovation. Then space exploration and navigation. By using quantum mechanics, we can make GPS, which would be very helpful for our explorations. Then let's go to the third slide. We know about the university. Then now we are going to know about India. India's quantum leap. In the National Quantum Mission, India is investing 6,000 plus crore of money. Then ISRO and DRDO are making encrypted satellites and for their defenses. IITs and IICs are making global leaders for this research. And India is acting as quantum innovation hub for the global south. This is the India's lead. And those are the pictures, like that is a picture of National Quantum Mission, that is the logo. And this is the cryptography of the spacelite. And there is the global meeting of the scientists of India of 2025, the International Year of Quantum. Then let's go to the fourth slide. The challenges in high cost and infrastructure needs. As the quantum computers are very fragile and need to be stored in 0 degrees Celsius, it is very high costed. Because if we destroy that one thing, that would lead to loss of millions of dollars in the cash. Then our extreme technical complexity. As these kind of computers use qubits rather than the bytes, and because of that we have a technical complexity. Talent shortage. Fewer people are interested in quantum mechanics, and because of that we have a talent shortage in the global level. Then slow commercialization. Having a high cost and some of the challenges, we have a very commercial issue because we cannot launch this kind of thing to the industries and for the market, and because of that we have a slow commercialization. Ethical and geopolitical risk. Some countries are fully developed, and because of that, they can go from far away from us, and they leave the smaller countries behind. And because of that they have a high-level geopolitical risk, and also a new arms race can be started. Then cyber security. In cyber security, some people may do things like to hacking or to break the encryption code, etc. and etc. Then what is India having a challenge? In India, people are less interested, as I talked about the talent shortage, but India is lacking of collaborations and some kind of talents, and because of that we have a talent shortage, and because of that India is having a challenge to compete in world level. And let's come to the fifth slide. The call to action, a quantum future for all. In this, we have to foster quantum education in schools and universities from an earlier age. Because of that, we have an advantage for the students to learn things. Then we have to build global and theoretical quantum research, and because of that, we have to make the students or the university students to meet and make some kind of collaborations. Like 7 countries already make the collaboration, like G7 Quantum Action. In these quantum actions, UK, America, and Canada, Japan, etc. countries are together on this quantum action. And that is the picture of students learning about the quantum mechanics. Then the third topic is invest in startups and innovation of ecosystem. We have to invest in ecosystem for our better future. And at last, I will conclude my seminar by saying a quotation of Nelson Mandela that the greatest glory in living lies not in never falling, but in rising every time we fall. That means if we take the challenges head on, we will make a brighter future of quantum. Imagine a future where we are living with quantum technologies, like that kind of advantages, like quantum computer, quantum communications, etc., etc. things. And because of that, we are making this kind of thing. So we are